Of 125, and because I added a blank on the left, I'll go ahead and add a blank on the right. I'm going to change my pen color here, and then we're going to fill the blank. So inside here I have -2 is my middle term. I'll take half of this coefficient. Half of -2 is -1, and I square it. So -1 squared is 1. That's what I'm putting in this blank. On this blank I'm going to put -25 times 1, which is -25. So that's going to be that. So now I have a completed square for this part right here. So I have 4x squared minus 25 times this completed square, which is y, and then half of -2 is -1, all squared. And this will equal 125 minus 25, which is 100. Okay? So now that I have that, since it's a hyperbola, I want it to equal 1. I always want it to equal 1, and it doesn't. So I'm going to have to make it so by dividing everything by 100. That's what I'm going to do. So 4 over 100 is 1 over 25. So we're going to say this is x squared over 25. 25 over 100 is 1/4, so it's minus y minus 1 squared all over 4. And this will equal 100 divided by itself, which is 1. So this is the equation of the hyperbola, okay, in standard form. So first thing I'm going to do is find my center point. I'm going to go ahead and label that over here. I'm going to find the center. So the center will be a coordinate. And right here, x has no numbers added to it, so that will be a 0. And when I get something added or subtracted to the y, I'll look at this number here, which is -1. I'm going to flip the sign, so it's going to become +1. That's where the center is, 0, 1, right there on the graph. I look underneath x squared and I see 25. I'll take the square root of that. So the square root of 25 is plus or minus 5. So because it's underneath the x, from the center I'm going to go over 1, 2, 3, 4, 5. And to the other side, to -5. 1, 2, 3, 4, 5. So go left and right for the x, and then here underneath the y I have a 4, so the square root of 4 is 2. So I'm going to go up 2 from the center and down 2 from the center. Alright, and here from this point I'm going to make this not so subtle looking rectangle with these outside points. And this board is wanting to auto select what I have here. So what I'm going to do now is from this box that I've made, put the corners down, and I'm going to go through the center here. Ooh, I did this again. I keep doing this one. Did this in class, so excuse this here. Rather than restart this video, I'm just going to erase this. I keep doing this, and I don't know why I'm having trouble counting. But I'm going to go, let's put this red dot in here. I'm going to go 2 up and supposed to go 2 down, so I should be right here. That's really where I should be. And I did it in class, I think during 3rd period. Same thing as some of you will recall. So that's what it should look like. I'm going to connect these corners here through the center. So I'm going to do that. This is going to be an asymptote right here. Let's see where my pen went. Oh. There we go. Get my pen back, maybe. And for here, I have... Alright, so we're going to make an asymptote connecting here. I'm going to try to anyway, through the center. And because this equation starts with an x, we're going to open up the parabola sideways, left and right. If it starts with a y, we open it up and down. So here's my vertex right here. We're going to open this, sorry, it's not a parabola, it's a hyperbola. We're going to open the hyperbola this way and this way toward these asymptotes, but not actually crossing them. And here we're going to open it this way as such. So that's kind of what's happening here. So it's not a great drawing, but it's going to look like that, kind of. And if you recall, what I want you to do is, for the hyperbolas, is to find three things: the vertices, the equations of the asymptotes, and the foci. So we have the center. So let's go and find the vertices first. And let's get a pin color I can see. Right here, this is a vertex, this is a vertex. That's where the graph will start, the starting points for the graph. So I'm going to go ahead and find that. I'm going to say the vertices, we're going to call them. The vertices. This one will be -5 and 1. And this other one will be 5 and 1. Those are the coordinates of the vertices, so that's done immediately. The equations of the asymptotes, this follows a very specific format. And I'm going to go and write that here. Asymptotes. We're going to use this equation. It's point slope form of a line. Y minus k is equal to plus or minus b over a times x minus h. Okay? So, h and k, if you recall, is the center point. So h is 0 and k is 1. That's what we're going to plug into this h and k here. Also, for the hyperbola, the biggest number, or the one that comes first actually, is a squared always. So a squared is this one, and the one that comes second always for the hyperbola is b squared. So I'm going to tell you that a is the square root of 25, which is 5. So a is 5. And from here, b squared is 4, so b is the square root of 4 is 2. Okay, so 5 and 2 are my b and a, and that's what I have, this and this. Okay, so what I'm basically going to have is y minus k. Remember that k is what? K is 1 over here. Is equal to, plus or minus, b over a, which is 2 over 5, times x minus h, and h is 0. So there is no h. So what's really happening here, if you need me to explain, is that I have an asymptote here that's starting from this point. You can't see that. Let's get a different color. Always find a color you can't see. And I don't have many to choose from. So I'm going to start here. I'm going to go rise over run. Okay. This distance here, the short side, which is underneath the y, mind you, is b. So b is 2, and a, which is right here, is the 5. So if I go rise over run for this line, the slope would be 2 over 5. From here down to this point, I'm going to go down b, and over a. So this is up b and over a, and this is down b over a. That's why I say plus or minus, because we have two lines. One of them is increasing, the other one is decreasing. So all I really have to do is take this minus 1 here and add 1 to both sides of this equation. So these cancel out. Now I have two equations. Okay, I'll have y equals positive 2/5 x plus 1. And the other equation I'll have is y equals negative 2/5 x plus 1. And these are actually the two equations that make up my asymptotes right here. One of them is increasing, the other one is decreasing. So those are the equations of the asymptotes. The last thing I asked you to find were the foci. Alright, this is done pretty straightforward using the Pythagorean Theorem. So what's going on here is I have B going this way and A going this way, and I have another point on the inside of it called C. This distance here is C from the center, so we'll call this C. It's going on the inside, somewhere on the inside of this shape here, inside this graph, and it's going to go the other side as well, just inside somewhere of that. Now, that distance is C, and I find that distance C by using the Pythagorean Theorem. C squared equals A squared plus B squared. I have already declared that A squared is 25 and B squared is 4. So basically C squared is 25 plus 4. So C squared is 29. So C is going to be plus or minus root 29. So from the center, I'm going to go root 29 this direction and root 29 that direction and get the coordinates of my foci. So what I'm going to do then is say, okay, the center is at what? 0, 1. Since I'm moving left and right to get to here through the transverse axis here, I'm going to add only to the x. The y is not going to change. It's going to be the same throughout. So it's always going to be 1, but this is going to change. So I have 0 plus root 29 for this point, which is just what? Which is just root 29. So I say root 29 and 1 is this foci. One of them, right? Focus is a singular, plural is foci. And this other one over here will be negative root 29 and 1. Negative root 29 and 1. That's the other foci. Okay? So that's that. And those are that's it. It's pretty much everything. So hope that kind of makes sense. We're going to have to do a lot of review for the test next week, which will be probably Thursday, I'm guessing. Okay, so those are the asymptotes, the vertices, and the foci. That's all on number 1. This should move a little faster as we go through. So we're going to go on to number 2. This is a parabola. And the reason I know that is because the x has a square on it, but the y terms don't anywhere. So the first thing I like to do, just out of habit, is to get y by itself. So I'll move all these other terms to the right side over here. Okay. So if I move them, they change signs. So I'm going to say, first of all, y is equal to 2x squared plus 20x, and then plus 46. All right. Now the next step is I want to set the equation equal to 0 so I can complete a square. So y will become a 0. All right. And then what I'm going to do here is I'm going to go ahead and get rid of the constant again that I just had by subtracting it from both sides. Now essentially you could have said, why did I move it in the first place? It already was negative 46. I do it so I can write in standard form first so I can see what's going on. That's just something I like to do. It's just one extra step. It's not a big deal. So I've added 46 to both sides. Now, to complete a square, I want this constant in front of the x squared, this coefficient, to be a 1, and it's not. It's a 2, so I'm going to factor out that 2. I'm going to go ahead, I'm going to go ahead and put x squared here. And then what do I multiply 2 by? Where did my pen go? Pen's gone, right? Yeah, can't see it now. Finicky. So what I multiply 2 by to get 20? That answer is 10. And then I'm going to add a blank here. Alright. Now if I add a blank to this side, I don't have to add it to the other side. Alright, so what I'm going to do is take half of 10, which is 5, and square it, so I'll get 25. That's what I'm going to put in this blank. If I put a blank on the right, I need a blank on the left to keep it even. But what I'm going to put in this blank is not 25, but 2 times 25. 2 times 25 is 50. So I got 50 minus 46, which will be 4. And then I have a 2, and then I have a completed square here, okay? Which is now going to be x. Half of 10 is 5 squared. So the next thing I'm going to do is move this 4 over here. I'm going to move that 4 over here and make a negative. And then I'll put the y back. Where it was a 0, made it 0, and I'm going to turn it back to y. And what I have is a vertex form of a parabola. This equation here, vertex form. So it tells me the vertex. That's why it's called the vertex form. So the vertex is -5, the opposite of this one, and -4, as it is. So -5, -4 is right here. Nope, a little further than that. Undo that. It's going to be -5, -4 is down here. Okay. Now, let's go ahead and find, well, this thing is a y equals. So y equals for a parabola means it's going to open either up or down. Because this number in front is 2 and is positive, it's going to open upward. So it's going to go upward. And if I solve this top equation, divide both sides by 2, I'll get x plus 5 squared equals 2. Then I'll take the square root of both sides. So if I use this, is what I'm showing you, I'm trying to tell you. If I use this, what I'm going to end up getting is that 2 is equal to x plus 5 squared. So if I take the square root of both sides to get rid of this square, that means that x will equal -5 plus or minus root 2. Those will be my zeros, okay? As it turns out, though, root 2 is about 1.4. So -5 minus 1.4 is about -6.4, which is right about here, give or take, on the x-axis. -5 plus 1.4 would be about 3.6, right? So it's going to be kind of like right there, sort of. So what I end up getting is a parabola that's opening up this way and going upward. Okay, looks something like that. Okay, so that's what the parabola looks like. But there's a point right on the inside of it, not far inside of it, and another point on the outside of it. This is called a focus. And this will be the beginnings of a horizontal line called a directrix. Okay. And what happens here is I need to find a distance here from the vertex to the focus. It's a very short distance here. And I'm going to call that distance P. Okay. That distance is going to be called P. Alright, so I told you earlier from another lesson that P is 1 over 4a. That's the distance, and a is this number right here. That is a. So that means that it's 1 over 4 times 2, which is the same thing as 1 over 8. That's the distance P. So if I know the vertex, I just need to go 1/8 higher than that, and that'll give me the coordinate of the focus. Okay. So in doing so, I'm going to say, all right, if I'm going up from the center, I'm only going to add to the y. The x is not going to change. So the focus has an x coordinate of -5. But if I add an eighth to -4, okay, keep in mind that -4 is the same thing as -32 over 8. This is true. This divided by this is -4. So if I add an eighth to it, then it's going to give me what? -31 over 8. And that's going to be the y coordinate for this focus. So I have the coordinate of the focus. I also want the equation of the directrix. Remember, this distance here is also P from the vertex. This is another value P right here. Okay, it's the same distance the other direction. So that'll give me a point here on the directrix, and then I can give you the equation. So in this case, I'm going to, instead of adding 1/8, I'm going to subtract 1/8, right? So if I subtract 1/8, -32 minus 1 is -33 over 8. That is this point, and it's also the equation of the directrix. It's y equals, since it's a horizontal line, -33 over 8. That's the equation of the directrix. So I found the focus and the directrix, which is what I asked you for in the question. Okay. For the parabolas, find the vertex, got it. The focus, got it, and the equation of the directrix. So I got them all. All right. So that's all that for that one. Let's go on to the next page, and we'll finish this up. Okay. By looking at this equation, I can tell right away it's an ellipse. Okay, I have x squared and y squared. They're both positive, but they have different coefficients. One of them is 4, and the other one is 1. So because they're different, it's going to be an ellipse. If they were the same, I would hazard a guess it's a circle. Okay, which is a special type of ellipse. So what we're going to do now is say, okay, do we have any other x's besides this one? The answer is no. So I'll just copy 4x squared. It's a completed square already. Okay, it's 2x times 2x, which is 4x squared. So now I'm looking at the y's, and I have a couple of those. So I'm going to go ahead and add y squared and 2y. And because there's no other y's, I'm going to say, okay, I need to add a blank here so that I can complete this square. And then negative 15 will move over here, and I'll make it positive 15. That's the constant that always moves over. So this equals 15, this whole equation. And I'm going to add a blank, because I have a blank here, and I have to fill it with something, and I'll have to put a blank there too. Now, half of 2 is 1. I'll square it, and it's 1. There's nothing to multiply this by, so it's going to just be the same over here. It's 1. So what I have now is 4x squared plus a completed square, which is y plus 1 all squared, because 1 is half of 2. And this will equal 16. 15 plus 1. An ellipse equation, just like the hyperbola, should equal 0 in standard form. So I'm going to go ahead and divide everything by 16 so I can get that. I'm sorry, it should not equal 0, it should equal 1. It should equal 1 in standard form. So I'm going to get that 1 by dividing everything by 16. So 4 over 16 is 1/4. So it's going to be x squared over 4. This is going to be just as it's written. It's already a fraction that's reduced. So it's y plus 1 squared over 16. And this will be 16 divided by itself, which is 1. This is the standard form equation for an ellipse. Alright. So, what I'm going to say then is, where's the center at? Center. Okay, there's nothing added to this x. It's 0. So the center x value is 0. For the y, I'll switch the sign of this number next to it, so it'll be -1. So that's the center, 0, -1, right on the graph. Okay. Underneath x is 4. I'll take the square root of that, which is plus or minus 2. So from the center, I'll go to the right 2 and to the left by 2. Underneath this y, I have a 16. The square root of 16 is 4. So from the center, I'll go up 1, 2, 3, 4, and down 1, 2, 3, 4. And then what I have here, when I connect my little dots, even though I don't draw it very well, is something that looks like an ellipse. Okay. Now we have to find the vertex and the foci for this. The vertices are on the long axis called the major axes. The vertex is right here, and there's another one down here. So the vertices, we'll call them, the coordinates for those is going to be 0, 3. And the other one is going to be 0, -5. It doesn't ask me for it, but I'll go ahead and find this anyway. On this side and this side, along the minor axis, this is the minor axis, this is called a co-vertices, right here, co-vertices. These right here. Let's go ahead and list those, co-vertices. So that's going to be -2, -1. And the other one's going to be 2 and 1. 2 and -1, sorry. So those are those. Now, what I'm telling you, what I'm declaring, is that a is the square of the bigger number. So a is the square root of 16. So a is going to be 4. B is the square root of the smaller number on the bottom, which is 4. So b will be 2. So what I'm telling you is that the long major axis, this distance here is called a. And this distance here is called b. Okay, that's what I'm basically telling you. Now, somewhere along this, okay, if I took this a length right here and I started here, if I drew a segment, toward here, and I called this the same distance a, so this length is the same as this length, I would end up at a point here, and I would call that a focus. So plural, I'd have 2 of them, one on each side, one on the top here and one on the bottom down here. This would be called foci. And I have to figure out what these are. And it's given by this distance here, the shorter distance, which I call c. So I'm going to use the Pythagorean Theorem again, except instead of saying c squared equals a squared plus b squared, instead of putting a plus, I'm going to put a minus. C squared equals a squared minus b squared. This is the case of the ellipse. So I'm going to say a squared is what? 4 squared, which is 16. And b squared is 2 squared, which is 4. So that's going to equal my c squared. So c squared is going to equal 12. So c is going to equal plus or minus the square root of 12. Or if you want to simplify that further, you could say plus or minus 2 root 3. But I'm going to use root 12 for this anyway, although you could call it that. So this focus here, these foci, have coordinates. We're not changing the x-coordinate of the center because we're not going left and right from the center. We're just going up and down, so it's going to be 0 still. But we're going to add root 12 to -1. So I'm going to say this is -1 plus root 12. That is one of the coordinates of the foci. This other one, and remember root 12, right? Root 12, it's in between the square root of 9 and the square root of 16, so it's between 3 and 4. So from the center, I should count 1, 2, 3, and go a little further. It's a little past 3, in between 3 and 4. So go 1, 2, 3. So it's actually down here, ways really close to the end. And this is the focus. And this one's going to be 0, and instead of -1 plus root 12, it'll be -1 minus root 12. And that will be the other one for the foci right here. So that's how you find those. Okay, kind of makes sense. And then we're on to the last one, number 4. Okay, this is a circle. The x squared and y squared are both positive, and the coefficients are the same. So it's it's going to be a circle. So let's go ahead and work that out. Let's go ahead and write the x squared first. Get the x terms. I have this one too, so I'm going to put -4x. No other x terms, so I'm going to add a blank because we're going to complete a square. Now let's go on to the y terms. I have y squared first, and then -6y. No other y's, so I'll put a blank to complete a square. I'll take this 4 and move it to the other side and make it negative. So I have a -4 and then plus 2 blanks. Okay, because I have 2 blanks on the left, I need 2 blanks on the right. So let's fill those in. Half of -4 is -2, square that, so it's 4. So we're going to add 4 on this side. Half of -6 is -3, we square that, so it's 9. So we're going to add 9 on this side. This -4 and this +4 cancel. So I have a completed square here, which is now x and half of -4, which is -2 all squared, plus y minus 3 all squared equals 9. Okay, because the numbers in front of these parentheses are the same, they're both 1, this is a circle. This is simplified. We don't have to do anymore. All I have to do is locate the center and find the radius. That's all I ask you to do. Well, this is equal to r squared. So r squared is 9. So the radius will be the square root of 9, which will be 3. The center, it has to be +3, mind you, because you can't have a negative radius. But the center will be located at 2, 3. That's where the center will be. So it'll be 2, 3, which is right here. And because the radius is 3, we're going to go 3 up, 3 down, 3 to the right, 3 to the left. And then we'll kind of try to connect these in a circular fashion. So that would be the graph, okay? And that's what it is. So I only ask you for the center and the radius. The circle is the easiest of the conic sections to figure out. And that's your video. So I hope you spend some time watching this. This is really not that complicated. We'll practice it more throughout the week, but you do need to try a quiz. And like I said, if you don't do well on it, don't sweat it. You'll have other opportunities to make up that grade. If you complete this review, you get to use it on the quiz tomorrow. So good luck. All right, bye.